firstly, before I even read the question, I am going to scroll all the way down and look for the two magic sentences that tell me what am I supposed to do. So the first magic sentence is here. Test the relationship between two things, T and R. So I already in my mind, oh, got T, got R. Okay, so these are my controlled, one of dependent, one is independent variable. The second magic sentence is, in every question one, there will be at least one or two unknowns that you need to find. That will be here. How to use your graph, gradient intercept, to find these two things, K and VL. So I must make sure that later I write an equation for these two, K and VL. Okay, so this is the start of the thing. Straight away, I come question one, I look at this, I try to find these two sentences already. Now I read the thing and try to think, okay, T and R. What is T and R? What is K and VL? So we have here a capacitor-resistor circuit like this. Got input, got output. Neon lamp flash on and off when connected across the capacitor with a PD of 90 volt. Oh, I read this sentence alone, I already know, I can draw neon lamp across the output. Okay, how to draw neon lamp like this? This is light bulb, not correct. Neon lamp, if you don't know how to draw neon lamp, you can just draw a light bulb and say label neon lamp. But the actual symbol, if you want to draw a neon lamp symbol, it looks something like this. It's got two plates inside a glass container with some gas inside. So got a dot like this. This is the official symbol of neon lamp. It's not in our, I don't think it's in our syllabus, so, but FYI lah, this is neon lamp. So it will on when the VF is approximately 90 volts. So where is VF? Across the lamp. So if I connect some kind of something that can measure voltage here, this will be VF. 90, then it will on. Now, if you don't know what's a neon lamp, Google lah. At least you just search neon discharge lamp. We kind of learn it in chapter 25. But you see the color one, these are all neon lamp. Or you go laser tag, you see all these colorful glowing kind of thing. All these are neon lamps. So here, this is a symbol, orange color one. Generally, it's the color of it lah. Okay, so that is your neon lamp that you will be using here for a small discharge lamp. Now, what else are we doing the neon lamp? Okay, so this thing will be flashing on and off. Now, you have a number of unmarked resistor. The thing unmarked here means you cannot tell what is the resistance of this one. We don't know. If not, usually a resistor, they will write on the resistor one like 50 ohm. You can tell one. But unmarked, you don't know what's the resistance. Okay. It's suggested that the period of the flashes, so this lamp is flashing, is related to resistance. Oh, so this resistor, I should write a story here. This resistor affects the period where your lamp will turn on and off. So period T of flashes of the lamp. So you adjust R, you will affect the period. Then you have this equation, T RCK. Constant K is this whole thing. Walao. VI is the potential difference across the input. So from there, probably need to measure VI, right? Where is VI? Input. Okay, so I need some power supply here. I will, for now, put a wire here first. Not yet draw. But this one is VI. Potential difference. Okay. Alright, I think we should start planning already. So that's the main idea. Just from reading, I can kind of gauge a few things to add to my diagram. So whenever I'm doing question 1, that means I always miss out everything. I write 2 pages also only get a few marks. You see, you need to write the correct thing. So a tip is, when you see equation, you just write all the alphabet in the list. Now what do I mean by that? This is where on the paper or down there in the space, you write. So the few things that you need to know is TRC. So I'm going to make a list here already. T, R, maybe I should leave more space a bit. T, R, C. K is a constant, but you will expand sub into here. So inside the K got VI, what else? VL, VF. I make this list or I make sure I mention each of them in my points, but now we're just doing point form. So each one will be at least 1 mark or so. So now we need to plan. T is period of the light flashing. Sometimes it will on, off, on, off, on, off. How do you know what's the period? You could use a stopwatch, number 1, to measure the period, or the more professional way is to use a CRO. Huh? You can see when you on already got voltage. So instead of a voltmeter here, maybe I'm going to upgrade a bit to a CRO. And this CRO later can measure voltage also lah, but can use CRO to measure time. So this one here, CRO. What else do we need to do with time? Take average of time, yes. Oh, this is our variable, the dependent variable. You change resistor already, your time will change. So I'm going to make a note here, dV. So this will be measured. Take average. How to take average? You take average by measuring 10 period of flashes. Remember, you all do pendulum? You all take 10 oscillation and then divide by 10. This is averaging time. Whenever there's a time-based experiment, you can take multiple oscillation, especially if it's oscillation one, 10T. What else can we do with time? If you are using CRO, there is more marks that you can gain if you talk about how to use the CRO. So you must mention, I draw a CRO screen here. Remember your CRO, right? If you got a wave there, you will only get divisions. So if you want to measure, let's say from here to here, and it's 3 division or 3 boxes. I'll draw 3 boxes. You need to multiply by time-based setting. So you say the period will be whatever period of the wave will be the time base times the wave of whatever wave or whatever pattern you see there. So you can say length of wave. Just generic length of wave. Okay, I think that's all. That's only if you use a CRO. So it's better if you use CRO. If you just say stopwatch, harder. You cannot talk about time base. More marks for CRO. Okay, that's time. Resistance. How do we measure resistance for this fella? The shortcut way is to just use an ohm meter. Use ohm meter. Okay, how to use ohm meter? You must connect a separate circuit. This resistor you take out. First you take out. Because got many unmarked resistor. So you take out your resistor and you can connect. Draw up here. No, I draw here. Take the resistor, put here. Take the ohm meter and just connect across the ends like this. And then you measure resistance already. The more professional way is to use, or that might gain you more marks, is to use a ammeter plus voltmeter. Got another method. Voltmeter. So in this setup, you will need to give a battery power supply to the resistor, but you need to measure current and also voltage. So current and voltage. Why we do this? Okay, let's say battery is 9 volt, right? You will know the potential difference across this resistor V, but you also know the current going through the resistor I. Oh, can you think of an equation? Got V, got I, you want to find R. So you use ammeter, voltmeter and calculate with VIR. Ohm's law. So this one I think is 2 marks. This one is 1 mark. If you want to use the shortcut method, can. If you use a more complicated one, can, but you must be able to explain. So measure resistance, 2 methods. What else? Capacitance. How to measure capacitance of a capacitor? Did they say this capacitor is unmarked? I go back and see. No. Resistor, they say unmarked, yes lah. Unmarked means don't have writing on the resistor. But capacitor, they didn't say unmarked. Means we can find the capacitance from capacitor. So let me see. Capacitor. So if we can Google, if you've never seen a capacitor up close, you will see they will write the capacitance there, 104 mu farad, or what is this, 47 microfarad. Wow, it's not very big. 220 microfarad. Yeah, usually they will write there one. So you just read lor. Look at the capacitor and you read. That's how you can check what the capacitance is. Okay, so I guess the shortcut is to read. Is there a long cut? Yes, but we'll save that for later. Wait first. We do that at the end. So the short method is to just read from the capacitor. You want to find capacitance? Read from capacitor. No problem. There's another method, but we will save that for later. It's a bit more complicated. You need a circuit, a capacitor circuit. Okay, pause there. What else we need? VI. What on earth is VI? VI is our potential difference across the input. So that's what they told us down here. So that will be this thing here. So, our circuit cannot work. We need power. What to put, AC or DC? It's a choice we have to make. I think for this one, the best choice would be to use DC power supply. So this one, DC. Very high voltage one. So I put there. So we need our VF here to reach at least 90 volt. At least 90 volt or more. So maybe I make that a note here. VF need to be at least 90 volt. So maybe my power supply, I choose something bigger, like 120 volt. Very high voltage. If you're wondering, Miss, then DC, how this lamp can flash? Okay, wait, we'll talk about that too. Miss, AC can or not? Cannot. You see, when you put AC with this capacitor, the capacitor will be in a mess. It will charge and discharge, charge and discharge. Think about this. AC, it's like this, right? Meow, 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 meow. This is voltage against time. But then you have a capacitor here. So this capacitor will try to smooth this voltage. But then, why got backwards one? The capacitor also don't know how to do already. So usually we don't use capacitor in AC, at least in A levels. The only reason where we use capacitor with some kind of AC is if it is already rectified, like this. Because most capacitor, you cannot simply change polarity one, I show you. This capacitor, you only can put negative to this leg. This one must be positive. You cannot simply change direction. You will burn the capacitor. So capacitors generally don't like AC. Don't work with AC. So be careful. If there's a capacitor, especially if there's a negative here, you only can put negative to this side. That's just generally how capacitors work. So because of the capacitor, we cannot AC. So this one, no. If it's already rectified, no problem. Capacitor will just smooth like that. Smooth. All positive, still okay. So no AC. No AC here for this setup. No. So DC is the way to go. But that asks another question. Then how does a lamp flash? Good question. Let's look and see first what the voltage is. So I'm going to just mention VI, we need to choose something large. But how do you make sure it's constant? Here is the two variable, right? So everything else should be constant. So you keep everything else constant. But how do you know it's constant or not? Best is to just put a voltmeter or CRO, up to you, to make sure this power supply, whatever it is constant. So use voltmeter. So let's mention this here. Use voltmeter to make sure it is constant. VL we're trying to find with the equation. So later we'll put an equation here. VF is 90 volt. We are going to use the CRO to check. So check with CRO or measure with CRO. Okay, I think that's the first part. Now what? I think we got most of our stuff down. on the list. Most of the variables here already there. Now let's go a little bit deeper into some of these things. So now we say use DC, right? Actually, but then Miss DC can make lamp flash, meh? Good question. Let's try build the circuit. Why not? Because we can. This one is the link. You can go try it out by yourself also. I also post in the chat. So that link, generally, you can go and build circuits. I hope it's working today. Sometimes it doesn't work. Then I'm like, GG. Doesn't work today. Aiyo. Why of all days you don't work today? Anyway, later if got time, you go and try build capacitor circuit lah. I will just manually draw it for you as an animation until it loads. Okay, let's look at it. Go try it out later lah if it loads. Okay, so how does DC create any kind of flashing light? So you gotta look this very carefully. The secret to this is to know how the neon lamp works. Neon lamp is not a normal lamp like a light bulb. It is a discharge tube. So let's dive into a little bit more of what a neon lamp is down here. So your neon lamp, very much like the symbol, looks like this. Got wire come in, got a plate, another plate, anode cathode, and this is all inside a glass tube in vacuum. See, it looks like the symbol, right? And inside here got a lot of gas, filled with neon gas. Now, neon gas by default is noble gas. It doesn't react with stuff, it's just chilling there. So what happens is when the battery or something else try to push current through here, current cannot enter, cannot pass. I mean, it's just all stuck here like pretty much almost like a capacitor like that lah. Current cannot pass. So it's like a dead end, the wire, dead end wire. So this is if your voltage is less than 90. So number one, I will write this out. For this neon lamp, if voltage, I think VF, right? I will check. VF is less than 90. Your lamp is off. No light come out. Why is it off? Because no current can flow lah. Okay, there's no light come out. So VF is 90 volt, lamp is off. No current can flow through the lamp. No current flow through lamp. Yeah. Number two, if VF is the potential between these two plates, by the way, VF. If it increase, then very big, about 90 or larger, wow, suddenly the lamp will turn on and it will start to glow. Why? So because there is current through lamp. So how to say I got current through lamp? I just write lah. Got current through lamp. Because now your gas can conduct electricity. Gas can conduct electricity. Kind of like the plasma globe that I brought to class one day. So if got current come in, usually current cannot pass through this gap one ma. But now, once you pass 90, your neon gas break down already. Suddenly, you can have electron go through and this is a current going through the lamp. Can pass only in more than 90. So what happens? Why current go through, then it will be bright. So you think about this way lah. Inside the gas here got a lot of electron inside this path that I draw. Electron, 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 electron. The electron will collide with the gas particle. So why got light is the question. Why got light? By the way, this one is this in syllabus. Kind of not really. Like you learn discharge lamp, but you don't learn how it create light. So maybe you can think of this. When the electron collide with a atom of neon, collide, ping, pong, 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 then this one become excited. Because the energy of the electron transfer to the neon now. So if you think of, you zoom into the neon gas, there are energy levels that looks like this. in neon atom. Okay, suddenly incoming electron collide with this fella, pom pom pom. What happened? You become excited also, so you go up. But then at some point, you will de-excite. So if you're up here, suddenly after a while, de-excite now. Go back down to ground state. When you de-excite, you release a certain color. The color is the color of neon, orangey color like that. Photon come out. And this color is what we see when the lamp start to glow. It's basically photon coming out lah. So once you on, there's photon coming out. Okay, so this is a side note, the theory behind it. This one, lecturer also don't know until a very long time. Then we see, we think, oh, actually neon gas is like this. Only 90 volt above breakdown, but this is for this particular lamp. Breakdown voltage. Okay, so if VF less than 90, lamp is off. VF more than 90, more than or equal to 90, your lamp turn on. That is all you need to know for this experiment. The other things, if you know, you know. If you don't know, it's okay. This is just paper 5. But for knowledge, this is how it works behind the scenes. So that means the lamp may not let current flow depending on the voltage. No current through lamp. That's because the resistance is kind of infinite lah. Very large resistance. But one current go through lamp, this resistance is almost 0. All the current can just go through like that, no problem. So you think about the circuit again. I'm going to go back to the circuit. This circuit, one question. How do we know to use neon one to use normal lamp? Here they tell you neon lamp, so you just assume that it's a neon lamp. Because if we think of our normal lamp, it will not flash. Because, let me show you. You gotta think of how circuits work now. So let's say I have a battery, capacitor, and normal light bulb. We put the X one on the symbol. How to show already? This one. Ayo, why so ugly one? Okay, never mind, light bulb. So if we connect this thing, and I close the circuit, what do you think is going to happen to the bulb? Will it flash? Will it just stay on? You all guess and see while I connect all the wire. Now electron inside there not flowing. So I close the switch. The capacitor will become charged. But then the bulb will just keep letting current pass only. Got flashing meh? No. Always steady like that. So if we just connect DC to a normal bulb, it's not going to flash. It will just keep letting current pass through it. And then the capacitor is forever charged. Then what for we put a capacitor here in the first place? Wasted. So yeah, not a filament lamp. Neon lamp. Because they told us a neon lamp and it doesn't work the same way as this one. This one always let electricity pass. Neon lamp may or may not let electricity pass, depending on the potential. It's quite a interesting lamp. So anyway, let's go back to the whole circuit. This one. Okay. We look here. How to think of this? Why will it flash? So this one is a good revision of capacitors because you need to understand how capacitors work. So let's say once upon a time, 120 volts, battery try to push current. Push where? Push here. Okay, say push here. Now, can this current go through neon lamp? Cannot. Cannot let it pass. Okay. No current can pass there. Not conducting. It's basically like a dead end like that. Nothing can pass. But current could go to the capacitor and charge it up. So when the lamp is off, the capacitor is charging in this loop here. So when lamp off, capacitor charging. How fast the capacitor charge? Depends on the R. Depend on R. Because if the current very big, then it charge very fast. So how fast it charge depends on the R. Okay. So as your capacitor charge, this potential will be increasing. So me right here, as you charge, VF increasing from 0. I just say increasing. If you're saying, Miss, why increase? Okay, you remember your capacitor? When fully charged here, what is the potential here? Okay, let's say fully charged, current cannot flow already. When your capacitor is fully charged, you have the same potential as the battery. But it doesn't get there immediately. It slowly charge to get there. That's how capacitors work. So you're charging a capacitor, it will increase, keep increasing. VF is the potential across this one. Potential difference, sorry. So if you want to see how the graph looks like, let's throw away this light bulb and throw away the wire and throw away this thing and throw away this thing. I'm going to put a capacitor here so we can see it slowly charge. Except that now I need to discharge the capacitor. You see charge now. I just throw away lah. Take a new one. Okay. So capacitor will slowly take time to charge. You can see that from a CRO if you connect it properly like this. You want to see the value? Okay, I put the value here. Connect here and connect here. Okay, so once I close, capacitor will start to charge. Why no charge one? Hang liao this thing. Oh, I paused the simulation. Okay, never mind. Put back everything. Okay, I close the switch. I run the simulation. You see this shape? It goes up. Charging. Almost reaching maximum now. Okay, so keep increasing. 89, 8.9999. Hey, stop at 9. Why 9? Because the battery is 9. So you slowly charge until 9. That's it already. Okay, so that is how capacitors work. Reminder of how it charges. Okay, now we go back to this. So how does that affect the lamp? You see, if you charge until maximum 120, then the lamp already activate at 90 volt. So you charge until 90, then it already activates. So what happens when the lamp activates? This is part 2. So once you pass 90 volts, your lamp will turn on. But why? Lamp on. That means now current can pass through the lamp. And the capacitor is going to be very happy because now the capacitor say, oh, I also can discharge through the lamp also. And the battery say, oh, I also can push current through the lamp. So now the current flow is something like this. Here, flow here. Capacitor also flow to the lamp, come out and go back to here. Okay, so this is what we call the discharging loop. Why so many color? I use orange color lah. Here. So capacitor discharge through the lamp. Battery also push current through the lamp. Everybody now want to go to the lamp because why? The resistance is like 0 like that when it's on. So when the lamp is on, the resistance of the lamp is kind of like almost 0. So everybody send charge there, all the current flow through there. So capacitor is now discharging mode. Pretty quickly actually. All discharge at once. As it discharge, now VF is decreasing. So the VF, so they're now discharging. VF will decrease until a certain point. Then the lamp's like, potential not enough. Okay, time to turn off. So the lamp will turn off. No more light. How to delete? Delete. No more current can flow. Lamp has now turned off. So where does the battery push current now? You cannot enter the lamp already. No entry. So then the battery's like, cannot go to lamp already. Okay, we go charge capacitor again. So you are switching between these lamp off, lamp on, lamp off, lamp on, lamp off, lamp on. That is how you can make this thing flash. But how does the graph look like? Can't we try to draw? So the graph that you will see on your CRO here, this is not required for you to draw, but it's good for you to know how it looks like. So you want to measure time, right? Actually, the CRO look like this, meh? No lah. CRO graph will look a bit different. So let's say we have an axis here. It's an axis of time and voltage. Horizontal is time, vertical voltage. So how will it look like? We got 2 stages. Stage 1, capacitor is charging. Right here, VF. Okay, charging, but the lamp is off. So all the current all flow through capacitor. So that means the capacitor's voltage will slowly increase from 0. Actually, why do I put this middle line? There's no negative value. Okay, we do this. Positive time. So this one is when the lamp is off. So capacitor slowly charge off. Suddenly you reach a point where you hit 90 volts. Hey, that's when the lamp turn on. So then the capacitor start to discharge very quickly. But you reach a certain point, the lamp will turn off. You start charging again. And then you discharge. Then you charge and discharge. So you see this sharp fin shape, up and down, up and down. So the green color is when capacitor is charging and the lamp is off. Then suddenly the lamp will on. When the lamp on, you are discharging. How to write? I don't know how to write sideways. Discharging. Capacitor discharge. Then you reach a certain point, the lamp is like, yeah, potential not enough already. I don't know how much, maybe 15 or something. Then the lamp will off. The moment the lamps turn off, then you start to charge again. Then you discharge, charge, discharge. So this is the flashing. When is the lamp on? On. Here, it will on again. So when you want to measure the period, you just take when it turn on, when it turn on again. So this is your period that you will see from CRO. Pew, 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 pew. Miss, is this in syllabus? No, it is not, but it's in the bonus video. If you go check out, I think 18 point something bonus video about capacitor graphs. Capacitor graphs. If you want to know more. But FYI, just like that lah. Exponential everywhere. Okay, I think that's the main thing I'm going to tell you about. The graph, how discharge lamp work. Okay, so remember there's 2 cycles. Charge, discharge. So I draw charging by battery. Then lamp turn on now. Oh, discharge this way. Lamp got light. Two stage. Okay, whew, that was a long experiment. Oh my goodness. It's so complicated, Miss. So what if you didn't know how neon lamp work? Can still do? Can. We did all this without knowing how exactly the neon lamp work. You just need to know how to spam your answers correctly and sound intelligent as you spam your answer, although you have no idea what is going on in the circuit. It's okay. That's question 1. You don't know, but you have a skill. You apply your skill. Do you know how to use ohmmeter? Do you know how to measure capacitance? Yes. Okay, then you just write. There's one more thing I wanted to add. Let me think first. You all said this first. What questions do you have? Well, I try to remember. Or before we go to the last part of the equations. Let's go to equations now. So these are all usually in the method part, problem part. Equation how? Miss, the equation is so long. If you haven't do it, I do with you now. Okay. So you want to plot T against R. That's why I say highlight the golden sentence. So straight away you know, plot a graph of what? RT, TR. You change the R, you get T. This should be a straight line. Because this is in the form, okay, so right here, T equals to RCK. So R is your axis, T is your axis. This is like Y equals to MX. No intercept. So this is your X. Okay, not too bad. But tell me you plot what graph against what. Oh, I just realized something very dangerous. You're changing R, right? One moment you have to choose 100 ohm resistor. The other one you have to choose 200 ohm. Isn't it a bit dangerous? Look at this circuit. This R you are changing. This voltage is 120. You use your hand and just take out the resistor like that. Won't die, man. You touch the resistor and you take out. Hey, danger. Here got danger. Such a high voltage supply, don't simply use your hand and take out the resistor. At least put a switch or something, turn off the circuit, then take out the resistor. Or you wear glove, rubber glove, then you take out resistor. So that's a safety precaution there. I guess we could add it here. Safety precaution for resistor. Turn off before changing resistor. Turn off circuit. Or you can use gloves. If not, 120 volt, you sort, can die. Okay. It's like putting your hand to the power plug. Don't try it. I tried it when I was a kid. Kind of. Was not a very pleasant feeling. I'm still alive, thankfully. Okay, and where are we? Okay, yeah. So you're changing R. You change all the resistor, and you don't stop yourself while changing resistor. Now we need to find equations for K and VL because we need to find out how to find this unknown from the graph. So you look, where is K? K is here. Maybe I rearrange this a bit. CKR. Then you can recognize CKR. So R is your x-axis. All this gradient. No? So you write there CK equals to gradient. And K equals to gradient over C. Very nice. This is the number one. So we have found one unknown from the graph. We need to find VL. Oh, where is VL? Oh my goodness. VL is inside here, inside a ln. Okay, we substitute the K first. Okay, so number two. Let's say this is ln Vi minus VL. I sub in the K. K I plug inside here, okay? Vi minus VL over Vi minus Vf equal to gradient over C. I'm just going to use M over C. If not later, the math's very long now. Okay, so from here, whatever I do, I need to make sure I take out the VL. How to do that? First thing, I open up the ln. So E to the M over C. Okay, and whatever is inside the ln just remain on this side. Okay, almost there. We need to express VL. So maybe I multiply both sides by this Vi minus Vf. So I'll get E M over C Vi over Vf equals to Vi minus VL. Oh, miss, this one working so long. Okay, last step. VL equals to Vi minus the whole thing. EM over C Vi minus Vf. Correct? Okay, correct now. So now I have an equation for VL, finally. So in my working, or in your working, somewhere you need to show K equals to gradient over C. How do you find K from your graph? Gradient, no? How do you find VL from your graph? Gradient, no? The M here is gradient. Write a reminder. This is the gradients. So please write out this whole equation somewhere. You see, as if this question not hard enough to give you a hard equation. Walao. Okay, so you go and plot lah, okay? So your graph, from graph, you can find gradient and calculate K and VL. I think this is pretty much it, the whole graph. So the last thing to add on to the experiment before I wrap it up is the advanced method of finding capacitance. So, forgot to write the equation here. So this one, we find equation below. Equation below, never mind our equation below. This is the unknown. Okay, the other one that I mentioned is how to measure capacitance. Can read from capacitor, yes. But if you see the mark scheme, they will say use some capacitor circuit. How to use the capacitor circuit to find capacitance? Use a circuit to calculate capacitance. That's pretty much what you need to say. I mean, you might want to mention draw the circuit, what to use. But how to use circuit to find capacitance? This one, I will tell you first, is out of syllabus lah. You have seen the equation in paper 5 before, many times actually. But in theory, no, we don't learn this in theory. It's in the bonus video section. But since it's in paper 5, why not we look at it? So here is battery. If you want to measure capacitance of a capacitor, here's what you can do. First, you connect with battery. One switch like this. Like that lah. Okay, so when I close this, it will charge. But I also want to discharge the capacitor. Why I put another one here? Delete. Discharge through something else here. I put a resistor to slow down so we can see the animation. So let's say I want to discharge. This is the second loop, just to discharge only. Like that. So your capacitor can either charge here or discharge here. So we want to see, okay, I show you. So you want to see how the capacitor charge and discharge. We put a CRO here. And you can also see the value. Now it's 0. Capacitor no charge, nothing, 0. Value is 0 volts. What happens when I close this switch? Capacitor will slowly charge. So pay attention to this graph, how it changes. And close the switch. Increase. So it's charging. It should go up to 9. Battery fully charged liao ma. So it's like your phone charging like that. 9. So now it's fully charged. I can open. Now this is the part where I'm going to use to calculate capacitor. So if I want to discharge this fella, you see all the charge stuck here, plus, plus, minus, minus. Discharge, I close this switch, then it will go around here. So you can see the current, the red color arrow flow. But look at the graph, it's decreasing. Where have we seen this shape before? Okay, slowly decrease to 0. It'll take a while. And 0. Where have we seen this shape? Okay, so charging looks like that. Discharging looks like that. Goes down to 0. Exponential decrease. Miss, correct. So your capacitor you can use the graph to find out how long it takes to discharge. So this is what I can do. Your circuit, okay, circuit. You can draw something like this: battery, capacitor, and the two-way switch. This is one you can call. Switch can change from here to here. I guess I put another resistor here, bah. Okay, so one side is to charge the capacitor, the other side is to discharge the capacitor. Discharge. And the discharge part is what we want to focus on, because the graph is going to look like this. Your voltage, if it's fully charged, you start off at the battery voltage. V battery. And then you go down. Like that. This one happens to be an equation that the pattern is kind of familiar, which is V equals to initial, which is V battery, E negative something T. The something is a constant, and this one you all didn't learn, but it's T over RC. This is constant. So if you want to say, okay, battery is 9 volt, okay, so battery start at 9 volt, drop down to 4 volt. How long does it take? 3 seconds maybe? Just now we see the animation. So then you can do this, V over V naught equals to E negative T over RC. So we can plug in, for example, drop to 4 from 9. Okay, 4. Up to you lah. Whatever value. E take 3 seconds. Resistor. Discharging here. Resistor is what? 10 ohm. Okay, then you put 10 inside here. And calculate the C. This is one way to do it. Wow, very complicated. Miss. Yeah, advanced way lah. So one question is, Miss, can we use correct power supply and ammeter to measure capacitance using Q equals to CV? Can we use that? That method is using the charging loop. So this one, you look at capacitor discharge. Number 2. Number 1, the other method is an approximation, so it will not be very accurate, but you can use that also. So this is using the charging loop, the orange color loop. So charging loop, you can do this. You need an ammeter inside here. So you calculate. You need QCV, right? QCV, that's right here. Q equals to CV. We want to find the C. We need to know Q and V. Q, we can find an approximate by using the current average times time. But you see it's average because it's not exact. So this one C times potential difference eventually when it's fully charged. So yes, you can use this one. You measure average current over time. But you see the problem is the current will change. So this is finding the average current. So this method can not as accurate. Average current. Because you are estimating with total charge using average current. Then you calculate C. C equals to IT over V. How long it take to charge? What's the potential at the end? Should be 9. battery ma. And what's the average current during the whole journey? So for more info, go and check out the bonus video on capacitors, how to think of charging, discharging. In this experiment, average current is 10 cert 2. That is for AC current. But is the current going to be like this? In this one, your average current is 10 cert. But I not cert 2. It's RMS current. But this is not an AC. This one, if you want to draw current, wow, to draw current. Do I have a current is actually going to be some weird shape like this also. Go down. T current. We don't learn this lah, but it's in the bonus video. Want to see how to see current. We are looking at charging. Okay, charging so on this side. So let's see. If you are charging, like this only so you have to spike and then you go down. You cannot see. I close for you all first. Hey, what's going on? Discharge, please. Okay, so at first no current then you'll see a spike and then it will decrease. This is current. Current is changing. How to average like that? Can lah. You can find average roughly. So this method is can do but not recommended. So discharge. I'll show you one last time. Can you faster discharge? Okay, thank you. So charging. Pause. This is the shape of the current. You roughly average you just choose something highest, lowest, divide by 2, something like that. But we don't use this method usually. Go check the marking for more info on what they require for this method. But for most of us, we're like, miss, too much problem now. We just read from capacitor can. Just read from capacitor can now. This method is just for knowledge lah, if you FYI. Okay, that's all for this question. What additional clarifications would you like to